Okay. Tumwamba.
Okay, so remember just from doing conduction, convection, and radiation, as methods of what heat transfer. And I promised you that I was going to come with questions. Okay, so I could revise some questions based on these things, convection, conduction, and what radiation. Now, there's one question that we've managed at least to source from one of the DAFRETs. The unfortunate part is that none of you here is having a DAFRET. So at least with some time we will try to look for this. Yeah, only one person. So we can continue from here. Now, below shows how a solar heater on a house roof is used to warm up water from a house. So if you can see here, we are having a setup point. This that you see here is a solar panel. How many of you have seen a solar geyser before? Solar geyser. I mean, I'm not a tank, so, but we call a solar panel. So, you've never seen those? No? When I go on a point, so they can't think active, so at least it's the first. Otherwise, you will take a lot of time. Alright, so listen. Now, this here you see is a tank. The tank is usually connected to the solar panel. Are we together?
Yes.
There are some pipes running through that solar panel. Are we together? Then here we've got a pump. Because it's a geyser, obviously it will be pumping water from this side going to the water, the tank. Are we together?
Yes.
Therefore, it's some cool over. So, having explained that, maybe we can come in. So we can see how we can answer some of the questions. So why is a panel, why is a solar panel? Okay, why is a solar heater painted black? Why is the solar heater painted black? You remember last time, was it yesterday I was talking about black?
Yes.
And I said this might come in the questions. It's obviously coming most of the times. So why is it painted black? Black is a very good absorber of water. So that's the answer I'm going to put here. Because black is a very good absorber of it. Black is a good absorber of it. Okay, good. Now the next part. They're saying, why is there an insulating layer behind the panel? Why do we have an insulating layer? Not one to insulation, fine. Why is there an insulating layer behind the panel? What is an insulator? Maybe we start from there to answer this question. What is an insulator? Or what does an insulator do? People look lost, I don't know what's happening. What does an insulator do? Okay, to prevent heat from? When you went to insulator, I'm not going to party in this topic, conduction, radiation, and convection. You part conduction and insulator. Conduction, So my question is, what is an insulator? If you remember the topic, what is an insulator? Okay, what is the other name for insulator? Maybe that way it could be easy. Serious. And I'm on serious note. Huh? Yes. You can give it a try. What is an insulator?
Something that
Thank you so much. So it's a bad conductor of it. As simple as that. You people are not going through your notes. And I can assure you this is going to cost you. Okay. So, to prevent loss of it, through water conduction line. So, an insulator prevents the loss of heat through conduction. Why are we saying loss of heat through conduction? Because insulators are very bad conductors of water heat. Are we together? Alright. Now the next question is saying, how does water in the tank get heated? My questions are answers, but there's no problem. Don't focus on writing. Focus on listening. So here we've got water in the tank. Right? The question is, how is the water in the tank getting heated? So the country Amboshta investigate for many Pichika. Why? Now you people, some of you have already told me here, you've seen them as solar keys. Okay, you've seen them before. But which part of the minutes one I want solar keys? So at least Zamara keys. Here is what happens. Yeah, that's how much better people here when they lift up their hands. So this is the sun, eh? Okay. Now this sun here is the one that is providing the heat to the solar panel, not so?
Yes.
Now on the solar panel, we've got a black panel here, down. Are we together? We said black is a very good absorber of water. Therefore, it is absorbing heat from where? From the sun. Bandeka. It is absorbing heat. This pipe here that you're seeing, or a network of pipes that you're seeing there, is in contact with the black panel. Are we together?
Yes.
It's like Nivokuirana. Are we together? So heat will be moving from the black panel to the pipe through what? Through conduction, not so. Because this the solids pipe na black panel. Liquidana, so the solids. There will be a transfer of heat from the black panel to the pipe. Are we together?
Yes.
So we have got radiation because the sun is a very hot source of it's a hot source. So it is producing heat. Are we together? And this heat we said that will be produced in form of water, infrared rays. You remember yesterday what I was saying? So my infrared rays, I think back through radiation. In a black panel here, that's absorb heat. Are we together? It transfers the heat to the pipe through conduction. Now in the pipe, what do we find? When the pipe is water. So in a pipe we expect water. That water, because of water, convection. They're getting heated because of convection. Now after they receive heat, they are transferring the heat to the water in the pipe. So in the tank, are we together? The water in the tank here is of course receiving the heat through convection. That's how the water gets heated, yes? Amanzi arimo kudara. Amanzi yali mu mumuli cyane. No problem. We can even explain it this other way. The sun produces infrared rays.
Yes.
Okay? So the sun is transferring heat to this black panel through radiation. The black panel has to absorb heat. What happens next is that it will transfer the heat to the pipe through conduction. Are we together?
Yes.
Even if we set the man's, okay? But the reason why I'm saying this water is because there's a pump here. Are we together? Now, even if we set the man's, do you know what will happen? This camera pipe is going to get water. Okay? Through conduction. Now it will transfer the heat from the pipe here to the water in the tank through convection. Are we together? The water in the tank, the water that is in the tank here inside, okay, will receive, in short, it's going to get heated up because of water convection. There are pans, many days of Kambira, there are pans, there will be a convection current happening. So the water here in the tank gets heated because of water convection. That's what we can say there. Now the reason why I'm saying there's water here is because of water, the pump. Obviously that water is moving like that and it's coming back. It's just being used to get the water inside the tank. Are we together?
Yes.
Now how do you write the answer to this question? Okay. You write it step by step, and I hope people will be following these steps. Right? The first thing you can say the solar panel receives it from the sun through radiation. can say the black panel then transfers this heat to the pipe through conduction aid. Okay, so hapa immediately hapa kinakamilisha the finally water in the tank receives the heat through convection. Now we can see I'm not asking you to memorize the answers right together. Please don't memorize the answers. Just try to understand the setup. Once you understand the setup from NAD, then at least you can have an idea on how you can answer these questions. Mind you that when a drawing is much to understand very most. Okay? It becomes a challenge. How can you begin to understand these setups? It's when you answer a lot of questions. It's the reason why I wanted that, and I was hoping that people would come with that phrase. Even if you don't pay for I was really hoping that. No, I was actually hoping that people know at least one or two people Anyway, so since we didn't do that, we can't waste time on something that does not happen. All right, so we can go on to this other question. Yeah, D. So D is saying on average, each square meter. Now this one is based on calculations. So I don't know if people have understood up to 5.C, so at least before the drawing. Let's see that you are drawing. Have people understood? Put the chat. But my calculations is something I can say. This one, they're based on calculations. Okay, so quickly, we move to DA. Now, I want people, if they are writing, please stop writing. In D, you won't understand it if you are writing. So listen, on average, each square meter of a panel, so solar panel receives 1,000 joules of energy from the sun every second. Now, using this information, calculate the power input in kilowatts of the panel if its surface area is 2 meters squared. Squared, question all right, so the line match. What is power? What is power? According to physics, work energy and power. Yeah, people are shy to lift up their hands. They don't know, scared. So what is power? Okay, very good. So it's a rate at which work is done. You can also say it's a rate at which energy is transferred.
So you're too fast.
Power is a rate at which energy is transferred.
It's a rate in which
at which energy is transferred. Yeah. Okay, so the amp of mind. Now listen. The reason why I'm writing this formula, it won't be yours. We're not going to use that formula. Okay? E. So the reason why we are writing this formula is because we want to use it to understand what is happening here. Okay? Energy is measured in what? The kind series of this power energy is measured in what? Energy is measured in what? Yeah, in joules. Time is measured in what? Okay. Let's go back to the question. On average, each square meter of the solar panel receives what? Number say 1,000 joules of energy from the sun every watt. So each time receives 1,000. Okay, 1,000 joules per watt second. It means we are generating about 1,000 watts. Because power is measured in what? Watts. We're generating 1,000 watts right together every second. Okay. Because it is receiving 1,000 joules of energy per second. Each square meter, just one square meter. Right together. Now the question here is calculate the power input in kilowatts, okay, of the panel if its surface area is 2 meters squared. So how many meters squared is the panel? 2 meters squared, right? You move the square meter, each will receive 1,000 joules, 1,000 watts. Each will generate 1,000 watts. So if there are 2 of them, they're going to generate how much? Very simple. Why is using a formula? We're just using this formula. You don't have to ask to understand what is happening. So we can say 1 square meter is producing 1,000 watts. Are we together? On the joules per second, will be a problem. So 2 square meters will produce what we don't know. Cross multiply mathematics 1 times x, x, right? 2 times 1,000, 2,000 watts. Why this is easy? Why? Because if you follow the question very well, it's saying we have to solve in how many? In what? In kilowatts, right? So animal watts, are they kilowatts? No. So how do you change to kilowatts? Divide by? A kilo is 1,000. So you divide by 1,000. Now we are going to have 1,000 into 2,000. 2 kilowatts, right? The answer is so by you didn't need to use this formula. You didn't need to use this formula. Okay, they can't stay so. Energy, the 1,000 joules and energy style receiver. Time 1 second. It passes 1,000 joules per second. The 1,000 joules per second, the same na 1,000 watts. Okay, ila 1,000 watts ndiye manje uzacha cross multiply uzapeza 2 kilowatts hapa, so kwa last time after much divide by 1,000. Alright, so let's go on E. Now E says, and I want you to listen to E because he na a very good trick. In there many trick chira na E and then shoka. So the question here is saying the solar heater in the diagram. In a diagram, maintenance and right? Yeah, has an efficiency of 60%. Meaning it wastes about 40% of the solar energy it receives. Are we together? 40% it's going to waste. What area of the panel is needed to deliver it at the same rate on average as a 3 kilowatt immersion water heater? Now when I'm going to say how many know what animation heater is? Okay. Bana fundisa hapo manzi kutenga katika shana. What do you call that again? Ka element. Yeah, karambia ka animation heater because mkachoso then mkafaka manzi. Kushita image ni kufaka manzi. Yes. Are we together? Yes. So it is animation water heater. Are we together?
Yes.
Now that one is not working like a geyser. Is it working like a geyser? No, but yours purpose is the mind.
Yes.
The fund is a man, so
Yes.
yeah, so that's what our interest is there. Now we are already told that the immersion heater is producing how many kilowatts? 3 kilowatts, right? So could be a problem. Tafaka outside the 3 kilowatts. Okay? But many what you use the solar heater is producing about okay, it's using only about 60% of the power. Yes. Mind nifuna vilingani, solar panel ya minutes zambo sentences. Nine immersion heater managed to produce 3 kilowatts. Are we together? Tufuna vilingani ma powers, ya managed to supply. Okay, after matusamo ila 40% ya waste. Nifuna kazi yangu sana na chani na 3 kilowatts. Are we together? So the math I'm going to do here is going to make you understand these two things. We are saying 60% of whatever we are generating, we don't want to be generating from a solar panel. Are we together? But it is supposed to be equal to what? 3 kilowatts. 3 kilowatts is the same as 3,000, eh?
Yes.
Watts. There's someone who's asking, I don't know what to ask it. Oh yeah, 100. 60% is this there over 100, 9% over 100. Yeah. Thank you so much for that correction. So now we can continue. We're saying 60% is what we want, eh?
Yes.
And that 60% of what we don't know is supposed to be equal to what? 3,000. Are we together?
Yes.
Now, 60 times x is 60x, not so.
Yes.
This is just 100. This is equal to 3,000. What's right?
Yes.
So this is over 1. We can cross multiply, and now we are going to have 60x is going to be equal to 100 times that is 300,000, not so?
Yes.
We divide both sides by 60. How much are you having? If you're having 5,000, you're right. 5,000 watts. Are we together? Now, once you've generated that 5,000 watts, the question is not asking how much power you'll be generating. That might come the question, if was at much. If was at what area? They're asking for the area of the panel. Are we together? What we need to produce about 5,000 watts. Are we together? The candy is somewhere. So how much area is needed to produce 5,000 watts? So taenda manjo. We will be saying 1,000 watts is equal to 1 meters squared. Maikumbuka 1 meter squared kwa mene choke?
Yes.
Papa hii question 9.
Yes.
1 meter squared. Ndia mene hizo shita produce 1,000 joules. 1,000 watts in short hapa kwa mene testa kwera. Are we together?
Yes.
Now if you've got 5,000 that we've just solved here. Watts. How much area are we needing? So you can see that 1,000 times x is 1,000 x. Eh?
Yes.
1 times 5,000 is 5,000. That's divide both sides by 1,000. How much are we having? X is equal to 5 meters what? Squared. 5 meters squared of the solar panel is what we are going to need. Now I know that some of you that may not have understood. So these are very much make a moves. We're using a mathematics here, right? So here. We are saying this one here is an immersion heater. Parimanja pamanjo maziwa immersion heater. The immersion heater is producing 3,000, so 3 kilowatts, which is the same as 3,000 watts. The solar panel, we don't know how much it is producing. All we know is that 60% is what we are using. So 60% of whatever we are producing is supposed to be equal to the immersion heater, because I say they're supposed to work at the same rate. Are we together? So 60% of whatever we are producing is supposed to be equal to 3,000 watts. Are we together? Yes. Mathematics. Now 60% is 60 over 100. Okay. If you do your math well, you're going to land with 5,000 here. Ukipasa mathematics, if unanipitia kwa mathematics sana. That pasira 5,000 watts.
So you are talking about percentage?
Yes. 60% is 60 over 100.
Yes.
Alright, so now we have 5,000 watts. Pamene hizo fumo sanifu na tupoendelea oxide. Now, when they produce 5,000 watts, right? Okay. Now, the question was, they were asking for the area of the panel.
Yes.
Okay. Now, we are already told that 1 square meter produces 1,000 watts, not so. If it was 12 capacity. Okay. Now, we will say 1,000 watts is producing 1 meter squared. Okay, 1 meter squared is producing 1,000 watts. So 5,000 watts, I'm going to solving now. That area, so you cross multiply there, you'll find that it will give you about 5 meters squared of the area. Are we together? Yeah. So give me my question. So how simple because area is measured in meters squared. They can give you some marks. This carried about 3 marks. So they can give you at least maybe 2 marks. Yeah, so Dave. Alright, I think we are done for our lesson. Unless maybe if there are any questions based on this. Are there any questions? Alright, so that simply means that page 120 near Pamela Paza Pezeka. Why do you have a tablet for physics? Okay. Of course, guys. Huh? I don't know what paper that was there. This is not a page. Sorry? That's the unfortunate part. I don't know exactly that way.
Sorry, I can't do it.
Alright, go there.
It's not true.
I'm going to pause it here.
It's not true.